Hey, here I am again. This short video I want to look at what polarization is. I have in this picture in front of me on the computer that you can see an object. It could be anything. It could be a sheet of paper. It could be like the aluminum can in the demonstration in the previous video. Doesn't matter. But we'll say it's neutral right now. And by neutral we mean we've got the same number of pluses and minuses, charges in this object. So if you add up all of the minus charges, maybe it's minus 25 in there. How many do I have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so it's got negative 25 charge because we've got all of those minus electrons in there, but we also have all those pluses, the same number of them. So I have plus 25 in blue, and I have minus 25 of those in red. So in total, I have a net charge of 0. So this object is neutral. Notice that I've got my pluses and minuses are right by each other. They're all nice and kind of uniformly distributed about this material. So you could say, like, maybe this is just a sheet of aluminum foil or a sheet of paper. Everything's nice and balanced out. So what happens with polarization? If I take an object like the PVC pipe I had in the little demonstration videos, and I charge it up by rubbing it on some like a wool sweater or something, then I can get a excess of charge on my PVC pipe. Let's call it just the PVC pipe. So this PVC pipe down here, this PVC pipe, which is plastic, all right, it has extra electrons on it now, extra electrons. And we can actually see exactly how many extra ones we have because we've got a pair of plus and minus there, a pair there, a pair there, a pair there, and then I have 1, 2, 3, 4. So this PVC pipe has a charge of minus 4. It has a charge of minus 4. Okay, so what happens when I take this PVC pipe that is charged with a minus 4 charge and bring it close to my neutral material? Something's going to happen. So say I grab it, I move it closer to my neutral material, and we'll say without touching it. I'm just bringing it close but not touching. Now these electrons here that are the extra electrons on my PVC, they're going to repel the electrons that are in this material. So if I take all of these electrons that I have in the neutral material and I grab them, we can illustrate what happens in polarization. These electrons are all going to get pushed to the right side a little bit of our material because they are repelled from their like charge. They're repelled from the other electrons on the PVC pipe. And that PVC pipe is net negative. So these electrons are going to shift over a little bit. There they go. So they've been shifted over because they're repelled by the electrons in our PVC pipe. It's net negative charge. And now I have the same number of pluses and minuses in my material. I still have 25 blue and 25 red. These are paired up, these are paired up, these are paired up, these are paired up. But now look, I have a side of kind of lonely electrons on one side, and on the other side of my material I have a legion of lonely positive charges. And so I have a positive side of my material, and now I have on the other end a negative side of my material. And so we say when this happens, this is now polarized. It's a polarized material. It's still neutral. It still has the same number of pluses and minuses, but by bringing something that's charged, this PVC pipe, close to the material that's neutral, by bringing that charged PVC pipe close, it changes the distribution of the electrons, so I get one side that's negative and one side is positive. Now if this material here, if it's like just a hanging piece of paper, it can move easily, then it's actually going to feel a force of attraction towards the PVC pipe that I'm just holding in my hand, and so you'll actually see it attracted, moved, even though this material is still neutral. We could do the same thing with, say, a glass rod. Maybe this is a glass rod which is happy to give up some of its electrons and become positively charged. So we bring that close to our neutral material, still the same neutral material with the same number of pluses and minus signs. What's going to happen here, we've got excess of positive charge. So let's say this thing has a charge of plus 3, so it's going to attract electrons in the material. So if we grab our electrons again, same thing we did last time, when that glass rod, which is net positive, comes close to our neutral material, it's going to attract the 25 electrons that we have in there, and shift them over slightly to the left instead of being repelled to the right. So they shift over, and now we have a neutral material that is become polarized. Now this is polarized. I have all these guys in the middle are still paired up, but I have my negative side that's now on the left because the electrons are being pulled towards the positively charged glass rod. And on the right side, I have my collection of plus charges that give me a positive side of my material on the right. So that's how we define, that's how we describe polarization. What is this? Go away. Get out of here. I don't need notifications right now. All right. So there's two examples of how you could polarize something without touching it. You can just bring a charged object close to a neutral object, and you can polarize the object, meaning it in a minus sign, kind of like saying a magnet is polarized. It has a north side and a south side. So you have a material now that's a positive side and a negative side. That's polarization.